You're in the home straight now. So esters form when acids and alcohols combine. When an acid and alcohol combines, it makes an ester. I can remember making esters in a test tube at school. I don't know if you can. And they made a product that smelled like pear drops. And in actual fact, all esters smell like fruit. They're sedative, antispasmodic. They're also antifungal and antimicrobial. Now, esters are interesting because in nature, they develop as a fruit ripens, so hence the sweetness. A very common example occurs in lavender, where linalool matures into linallyl acetate. So over time, the alcohol morphs into an ester. Now, when you do the lesson on lavender, you'll see why that's very interesting to know for people who are trying to devise medicines. Esters are really easy to find on your list of constituents. If you remember, 2 words. The first one will end in "ill", the second one will be "ate", linallyl acetate. Now, interestingly, mandarin oil is really rich in esters, but it's because tangerine oil doesn't really have any. And that's because in many cases mandarin is distilled from the leaves on the tree, whereas tangerine has been expressed from the exocarp. Although there can be distillations of tangerine as well. But it's interesting from lots of different angles. First of all, the properties of the oils are completely different, whereas if you pick them up you'd think they were similar. They're absolutely different. But also, because it is distilled, then your mandarin oil will last longer than your tangerine oil will. So if you want to look after your pennies, that's a good way of doing it, choosing mandarin over tangerine. But also, when we come to do the blending, the mandarin fragrance unfolds slowly, so it lasts longer on the skin. So that's down to differences in chemistry and down to differences in extraction. There's one particular ester that we'll quickly talk about that happens in great abundance in some essential oils, and that's methyl salicylate. It's really beneficial for muscular pain, and it's often found in liniments for arthritis, rheumatism, that kind of things. When it's been tested in the laboratory, it's more potent than aspirin for its pain-killing abilities. But if you overdose in this ester, it causes convulsions, irritation in the intestines, and but if you poison yourself with it, it's lethal in 50% of cases. The symptoms of overdosing can be nausea, vomiting, pulmonary edema, and pneumonia. Now, it's a scary sounding thing, isn't it? Now, if you use wintergreen oil is 98% methyl salicylate. Now, if you think that lots of old people have liniments with it already in, and then they use wintergreen oil, can have all sorts of problems. So this is something to be careful of. Watching out for, first do no harm, watching out for any other medications that somebody's in. Very interesting. Lactones and coumarans, very, very small group, and to be honest, they are more to do with perfumery than to do with aromatherapy. But a lactone is a carbon ring with an ester inserted, and coumarans are a type of lactone. Chemically they act in very similar way to how the ketones do. They can be neurotoxic, they can cause sensitization, and they can cause irritation, but the risks are usually quite low. Lactones though are like snow plows through congestion. So elecampane or inula oil is very high in lactones, and so if you've got a chest congestion, it goes bosh, smash, that's it, cough, splutter, gone. So oils in lactones are very, very useful. Coumarans, or specifically Furanocoumarans play a much bigger part, as I say, in perfumery, but they can be phototoxic, so in the sun they can make your skin go blotchy. One particular example of that is in bergamot oil, and quite often on the label you'll see bergamot FCF. That is bergamot furanocoumaran free. It's been taken out. So you've taken that coumaran out, so therefore you can use it and not worry about going blotchy in the sun. If it is in there, you don't really want to use it for 12 hours before you go into the sun. And that is chemistry.